Okay, back to where I was. Yeah, cool. Absolutely will not compile, but whatever. What was I doing? I don't even remember. Okay, let's actually go ahead and clean some of these up. And, I have an idea. I'm just gonna repeat myself. Oh wait, that's an AI generated. Hold on, I didn't read that. Okay, so we're just gonna run that every 10 seconds, just for the hell of it. Cool. So line 143, we got an issue. What's wrong? What's wrong, baby? Unidentified identifier server type. Yeah, I did mean that actually. Use of undeclared identifier server. Yeah, fair enough. Let's do this. We'll just toss this in there. Static. No. Type def struct server, and you are going to have a boolean, no, u8, what do we call it, executing, and then we do, we'll start that up right here, server star server is equal to malloc size of server, and then we can, yeah, so that should be fine. That's all we need. Oh, right. Server executing is equal to false. False. 0. And then at the end, free server. Okay. Okay, cool. What else? Software queue. Not defined. Valid. Perfectly valid. So let's start using CBs. Hope that doesn't need a parameter. Probably need a hardware queue too. Okay. Oh, need to import CB. Okay. No, we need server exec type. Or this is gonna be a U8, I think. Or this might completely break everything. I don't think it matters. It's only allocated once. Oh wait, we already have them. Let me just move them up. Where are they? Where are they? Here. Okay. Pop these in right there. I'll do static. Can we do const here? Because these aren't going to change. All right, let me do this. All right, what else? Server exec type. Oh, right. This whole thing, oh god. I'm gonna comment this out for now. It's not gonna. Okay, this is, never mind. This is distracting me. This constant rebuilding. There's like. This is gonna get really complicated really quickly. Okay, this is massive, but I'm actually gonna wipe this out because we figured it out. And it's in Git history, so we can just swap this out. Okay, what else? 330, I was still unhappy about this guy. Server exec type. If server queue size is, okay, there's not one server queue. And I don't really think there's anything in here that we need to keep, so this is gone, sorry. Go ahead, make main. Processing, it's not processing, it's executing. Wait, type 5, okay, we still got this thing. Do we need anything, okay, type 6 is gone, there's no, we're not doing this. Not sure about these event types. I am now. Okay. This is actually pretty valid. Let me. So end server execution, which is exactly what we want to do. Here, no. Exec end ID. Right there. Server processing is set to 0. No. If the software queue is not empty. Oh, this is just flipped. So packet, we need to build a packet. No, we don't. Wait. Okay. So this is when we get to the execution and we don't have any packets, which is weird. We just skip it. Or wait. Probably server executing is equal to 0. This is important. I mean, it should be handled here, but just in case. Okay. Execute packet ID, so we actually do something with it, which is going to be massive. But yeah, we do stop conversion. This is similar to this. Server execution. Yeah, so this guy reschedules itself, and we don't need a packet ID or anything. We just do that, which is exactly what we're doing here. So we can kind of wipe out this whole thing. So let's do that. And where are you? There. This whole if block is gone. There. All right, let's keep going. If type is wait, if we have start server exec. Okay, so this is similar to what we had, or what we just added more recently. Start ID. Here we go. So we don't actually do anything, do we? No. No, we schedule it. Pretty fair. Yeah, because no data is going to be available until we're done. So if server processing, we just skip it. This is identical. Then we do set it to 1. Oh wait, actually, we could do this first. If CB is empty, really weird. Wait. Let me think about this. CB is empty and executing. CB is empty and not executing. Not empty. CB is empty and executing on the last packet. We don't need to schedule anything. If it's empty and it's not executing, do nothing. If it's empty and executing, if it's not empty and it's executing, don't do anything, because it will. Not empty and not executing. This is the only case where we do something. So, if it's not empty and we do have an executor, okay, so this executing status is inherently tied to an exec and ID being scheduled. If those two are out of sync, it's not good. It's not good. This relies on the executing state and the fact that an exec and ID is scheduled to be in sync. Okay, so we can just do if there. Okay, so we do server executing 1. We don't actually handle the thing there. We don't need to do this. That'll be for the server end, but we do need to make sure that. Wait. We definitely do need to schedule this guy though. This is good. So I think we can get rid of this whole part now. Okay, so type 5 server exec has nothing in it. We can get rid of it. Okay. What is this? What the hell is going on here? Okay, well, type 2 and type 3 have nothing. We haven't even, there's nothing to delete, really. Client, okay, these will come later. Okay. Oh, we're down to 19 errors. Okay. 330, what's up with you? This is, oh, type 4, server in, okay. All this does is print. I mean, this is useful, but we're gonna move this elsewhere where it's actually gonna be used, and it's actually gonna be used in the end exec. That's when it actually gets from the network into the execution. So right here. This is critical code right here. All right. Any other stupid questions? 292. CB push. You should have CB push. What is this? Let's look at this. Let's see if we have this ready. So this is basically when we reach the hardware queue, and as you can see, yes, we have a, wait a minute, no, this is not, no, the param should be, what is this, hardware to, wait, what is this, no, it's not a, oh, it is in the hardware. Yeah, we put it on the hardware queue, and then we schedule a hardware to software ID. Yeah, so this guy will schedule this guy, which is good, which is exactly what we're doing here. Server in, hardware to software. And we push it on the hardware queue. This is nearly identical, except we don't actually look at the packet. We just schedule the ID. So this is good. We can get rid of that. Let me see where this comes from. Not here. There. Let me just go ahead and wipe that out real quick. This is loading onto the hardware queue. Okay, this is loading onto the software queue. So hardware to software ID. So when we actually get it, this is what we do. What do we do here? We pop it from the hardware queue. We push it onto the software queue. We schedule a start server exec, start ID. This is pretty much identical. But only if it's not empty. If it's empty, wait. Oh no, this is a reverse. Hold on. If it is empty, if it's empty, then we schedule it. If it's not empty, that means that there's something already in the software queue, and it's already scheduled a exec start ID. We don't need multiple exec start IDs. Trust me. There's just a waste of events. So, what do we want to call this? Oh, right. If it's not empty, someone has already scheduled an exec start ID. All right. Scheduled an exec start ID. All right, cool. So exec delay. Cool. We can wipe out this whole part, or this whole part. Enter into SW. Yeah, here. And now this is nothing but comments, so this folds up. And again, like, it does feel a little sad to get rid of these comments, but also they're all in Git. They're not gone. They're still there. If I want to go back and see them, I just browse it on GitHub or whatever. Let's take a look at this one. Client sockle toggle unconnected, disconnected. Yeah, this one's kind of tough. I'll get back to this one. Wait. Toggle socket client. So these are basically toggling the client on or off, and this one's client sockle toggle connected, disconnected. So is the web socket currently subscribed or not? Why even bother modeling this? For the love of the game, that's why. We could just have them, we could just hard code it, but nah, that's not fun. I'm just gonna open the window a bit more, get some fresh air. Listen to the lovely sounds of something. So this is completely gone. Boot type. I mean, there's really no difference between a computer that's off and a computer that's not connected. It's not like taking any process, I think. I don't know. Well, maybe we'll come back to this, but and even if we do need to bring it back, you're going to see how exactly we could pretty easily once you see what I'm going to do with a client toggle socket toggle. Boot has been removed. There is no difference between a computer that is off and a computer that is disconnected from the socket in this sim. And yeah, so we'll just do okay. Now, how exactly are we going to implement client socket toggle? Because it's one of the first things we do. Actually, my mic's fine, actually. Well, I think all we need to do, so packets and responses, as I'm going to call them, which is actually the next big important part. Let's see. So I have this diagram here. It's like server event. So when the order book updates, it makes a bunch of these responses, which is a list of client IDs to their snapshot address, and then they all go to the same snapshot of the order book. But for these response IDs, we could have some special values for that snapshot pointer, such as 0 or 1. It doesn't really matter too much. And I think that's exactly how I'm going to do it. And then we just take those. Wait a fucking minute. Yeah, then we just take those and we deliver them to the clients, kind of as like special. Oh, wait a minute. Oh, this is tricky. Okay, I do want to implement a boot event, but it's not going to look like a boot event. It's just going to look like a special packet from the server, like awaken, maybe type 0 or something. But let's get a make main first. Just get this building. Okay, only 7 errors. Cool. That's not too many. Where's obvious? Here we go. 2214. What do we got? Oh yeah, no client in type, no client out type. Only. Wait, did we not? Okay. Well, let's just do this. Static. U6. Const. I don't like that we're doing. Wait, this can be an 8. I think this can be an 8 because we're never. Oh no, we. If this is an 8, then this whole thing is a 8, which is not a good look. But let me just say this real quick. What is it? Server type is equal to 0. I'll switch back to this. Whatever. 64 server type. We have a client in type and we have a client out type. And then there's one more. Slow checker. Slow repeat type. This one will be 3, 1, 2. That's really the only events we need. We can wipe these out because we don't need them. Yeah, it's not server in type, it's just server type because it's more generic. Just like do something on the server, basically. All right, let's do this. Here. Server, okay, five errors, okay. Server in type. Yeah, I don't like that. 256 has an error, right? Oh, this is not needed. Wait. Oh shit. I think we deleted something I needed. Oh, fuck. Where'd it go? Oh. Okay. This is actually a pretty important calculation right here. This is oh, I should have documented this. I'll just make a note like this. 1.0 plus 0.0 divided by 7, that's 64. X plus 0.0 no, that's 1/28. 1/128 is about plus, oh, what the fuck? Okay, this is just base jitter, 325. This is just the bottom half, I believe. Wait, if it's the bottom half, this would always be 0, no? Oh, no. This would be 0. This would be 0. If we just AND it with the bottom 32 bits and then we shift it 32, yeah, it's gone. But if we multiply it by base jitter, which is a bit more interesting, then we can shift it and it's a bit more interesting. And then we shift it over by 5 more to get like some small values. This is something like 5, it's 1/32, which is roughly 0 to 0.03 x, something like that. All right, next. Oh, it can't actually be 0. No, okay, if rand is 0, wait, no, rand could be 0,0,0,1, so it could be 1, and we multiply base jitter. How big is base jitter? Base jitter is a UN64, so if UN64 is greater than, yeah, if it's 1, it'll just be 0. If random is 0, so whatever, could be 0. Let's keep going. Server in type online 256. Oh, right. This is really the only calculation I need to keep, so I'm gonna kind of rip this out and kind of shove it, I don't know, right here for now. Just have it in my back pocket. Oh. Okay. See what that looks like. Or 256 is gonna be completely messed up now. Type 1. Type is equal. Oh, this is the WebSocket thing. We're gonna do this differently. Packet P. Server type mask. Yeah, it's all the same thing. Packet ID. Oh. FL insert packets. This is pretty good. This is how you build a packet. So let me. Packets are server, are client to server, and they're gonna have a distinct. Difference. Distinctly different shape from server to client. Server to client is always going to be a little bit messier, a little bit bigger, I think. Maybe. Because client to server still needs to encode order information, including quantity, price, order, direction, maybe stop loss. Maybe you can modify an order. That's a whole possibility. All right, let's do this. Yeah, so we wipe out this whole thing. Maybe I'll keep a few of these just so we know how to do this. Yeah, this is probably the only thing we need. I'll kind of throw into this one as well. Okay, let's go back and rebuild. Um, 179 server in type. This is exec start ID, right? This is just a server type. It's not a server in type. Anything else? 36, easy one. Go. Oh, client in type. There you go. 61. Oh, wait, what? That is concerning. I'll come back to that in a second, but that is actually really concerning. Why did that suddenly pop up? God damn it, who has it open? You? What's wrong with you? Line 61, this is unused. Oh, there's a critical bug there. Yeah, whatever. Cool, you good? At least get rid of that warning. All right, cool. This is still in main. We only 2 errors now, 104. Boot type. What do you mean boot type is not? Oh, yeah, I guess it's not. Boot event. Actually schedule a client in event with a specific response, with specific values in the response. Whatever. We'll come back to that. Maybe 74. FL packet is equal to FLN, the size of packet. You needed 2. Why do you need 2? Reserved IDs. Yes, this is actually critical. This is going to be max reserved ID. This is equal to 3, but we need 4, so +1. Does that make sense? Max reserved ID. Oh no, wait. No, here we go. So 3 cannot be assigned. Yeah, alright, let's see what we got here. Okay, now we just have that boot type thing. Okay, 104. First boot. I mean, this is fine. Like this first boot and this, using it here is fine. Now for actual boot event, we're gonna need a new type. We're gonna need a completely new type. We're gonna call it, I mean, it's still, like in the grand scheme of things, it's still technically a packet, but we're gonna call it type def struct response. And this is response. And what are you gonna do? What are you gonna do? We're gonna need a U32 client ID and oh my god, I don't even know how to model this. I guess we call it a void star. So this will be, how many bytes is this going to be? This is going to be 64-bit machine. This will be 12 bytes, which is not ideal. We'll have to come back to that later. Maybe. Currently 12 bytes on 64-bit machine. Find a better way. Yeah, but the good thing is these responses, I mean, if I could shove all the information I needed into a single 64-bit client ID event, I would, but unfortunately this is like 20. Oh, wait a minute. This is not. Wait. No, that was a different way I was doing it. Hold on. This is actually going to be a U, probably a 32 as well. So this actually works out to 8. And this is going to be a snapshot ID. Now, of course, the problem is 0 is a perfectly valid snapshot ID in the. Actually, this is actually related to the bullshit store. So we have this MD start, MD end, MD capacity. I guess we could do something like, we could just reserve an empty space. I wonder how that would even work. Oh god, if size is 0 and we just reserve, we just call BS reserve for the special boot type. Let's take a look at BS again. Okay, who the fuck has it open, bro? Come on. Alright, you? Alright, what's up with you? Let's see how we get. Okay, so this BS reserve. Okay, this is annoying. BS reserve, line 42. Let's see what this returns exactly. Oh, fuck, I gotta go soon. Man, I never have enough time for anything, I swear to God. Return result. Result is MDN, so the index of the last metadata thing we just put in. I feel like we could just toss in a few more at like 0 and then just never free them, but that kind of breaks the whole principle. I guess, what would we do here? What would we do? Yeah, this is tricky. I'm leaning towards, this would be a little bit cleaner, but maybe like flag. So this returns, always returns BS end, which is where we just put the last block, the index of where we just put the last metadata. How can we avoid using a specific value of metadata? If we hit, oh God. The trick is here. The trick is right here. We can do, every time we set MD end, or MD start is equal to anything. MD end. If this lands on one of the lowest values that we want to reserve, we simply just bump it up. Yeah, we just simply bump it up. Let's see if we have any MD start setters. What is that called? This is a comparison. Here we go. Yeah, this is when we free it basically, but it's not just a simple free. It's yeah. Okay, hold on. Initial metadata index, metadata capacity. What do we need metadata capacity? Oh, because there's no clean way to copy it. Yeah, so this is fixed. This is fixed. Whatever value we choose for metadata capacity, like we should choose wisely and stick to it. This is basically how many different versions of the order book can be seen at one time, because different clients at different times, due to their network jitter, will see it at a different point in the past. Basically, like you can't immediately, like if a client is 100, let's say they're like 10 seconds away in latency, they're not going to be able to see what is right now. They're only going to be seeing 10 seconds ago, which is why we need this whole blob store thing. MD start at 0. So what I'm suggesting is a few special values here just to avoid collisions, because if we don't reserve anything, then we might have some metadata at these special values like 0 or 1, which are really just it could be like, maybe we only need 1. Maybe we just need 1 for like a boot event, and then, or socket connect event, and that might be it. Or maybe even like a socket disconnect event. That could be interesting. The fuck? That's kind of cool. Or even, we need a way to get to the client. We need a way to get to the client somehow. We need to kick off the client somehow. Otherwise, we need to just schedule them in some capacity. Because imagine you have a client that's never going to connect to a socket, and maybe he only turns on his phone like 1 month into the simulation. How do we schedule that 1 month event? Maybe we I think we need reserved values. I'm just scared of how this is going to affect things for the blob store. But I think it's the right move. We basically just, I mean, when we do this, when we do like this whole mod thing, we're basically pretending that all the values past MD end, or past the capacity, just don't exist. That's what we're doing. We're looping back around to them. So we can just pretend a few more values don't or we could do this even simpler by just choosing some values beyond capacity, which is going to be tricky because, okay, let's say how many snapshots could we need at one time? How many snapshots could we need at one time? The most snapshots we're going to need. So the biggest that this value could be. Oh my God, wait a minute. You know what? Snapshot ID isn't even enough, I think. Let me explain why. I actually think we do need something like this. Type. Unfortunately, it might not be enough to shove. We could fold it into the client ID too, because client ID, unless we want 2 billion clients, which kind of models, you know, most people on Earth, or a major minority of the people on Earth trading, but that's not really the case. Client ID. Okay, I think what we're actually going to do, and what I think we do is 39. So we actually have 7 more bits to play with here. So we could actually shove, client ID is actually what? We decided on 39 minus 2 minus, I can't do math right now, hold on, 64 minus 39 priority minus 2, 23. We have 23 bits. Wait, that's it? Wait. This is how many clients we can support, which might be fine. Wait, no, that's not okay. 2 to the 23. Fuck. I don't know. We'll come back. May actually be 23 bits. So maybe we put something into the top bits. Put flags. And the thing is, we actually do need some kind of flags, because it might not be enough to just have one snapshot ID. We might have multiple stores of snapshots. And in that case, we need to differentiate between those snapshots. Now, these snapshot IDs, the most snaps, if we put them all into one, if we put all the snapshots for various L1, L2, L3 data into a single snapshot, we might have something like 1 million, maybe 1 million clients are connected to a socket at the same time. Which means that we might only need something like, that's 1 million, yeah, 19, yeah, but 20, we only need 20 bits for the actual snapshot ID, because we'll reclaim old snapshot IDs as we take them, which means that the top bits of snapshot ID could actually be used for something interesting, which is kind of the whole pattern we've been doing here. So I think that's what I'm going to do. We're going to use the top, or an alternative is, we still have 1 million clients connected on one snapshot store. So we'll still need, 20 bits to identify which snapshot, but we might also store which specific blob store, because we might have multiple for L2, L3, L4, L1, L2, L3, and then we can kind of put that flag there. But let's try this. If top bits of snapshot ID will actually have some interesting things in them. Hopefully 1 million snapshots is enough, and I can actually tell you how much memory 1 million snapshots will take up. Let's say worst case scenario, each one is L3. Okay, level 3 data, so 1 million snapshots. We're looking at 32 plus m multiplied by 24 plus n times 32. I actually forget what these values are, but it's m is the number of like price levels, I think. Yeah, m is number of price levels. Let's say we have, I mean, can we just get this? Can we just look at it right now? Is this available? Okay, example, sample order book. Okay, was it CBO? Data bento and market by order. I think this is like the big one, right? Yeah. Sample MBO order book. I just need an idea. Here. Maybe. Oh, these are all the orders. Okay, got it. Oh, this looks nice. Oh, that's beautiful. Whoa. Holy shit. I've never seen anything so beautiful. Just kidding. Let's just say there's 100. It's 100 different prices. And then for each price, let's say we have 15. This is going to tell us how big this is in bytes. Or to be explicit, 4 billion. Wait, what am I talking about? A gigabyte is this. So we're looking at 46 bytes if we store 1 million snapshots of L3 data, which is not happening. Absolutely fucking not. I think for L3 client subscribers, we might have something more like maybe 4,000, like 4,000. All right, so hundreds of megabytes. That's more reasonable. For the actual, then we also have L2 data, which is L2 data is less than this. It's like MBP market by price. Can you show me an example? MBP data example. Just every order book event at the top price or across the MB1 schema. Here we go. Market by price. Every order book event across the top 10 price levels, keyed by price. So, so that calculation would look like. So M is explicitly 10, which, so this calculation, even for 1 million, will only be 4 gigabytes, but we're not going to have that many subscribers. Now, L1, every order book at the top price level, best bid and best offer. Every order book event, really, every order book event. Seriously, wait, L1 data. Fuck, gotta go soon. So this is M specifically 1, and then we're looking at half a gigabyte for L1 data, which is fine. It's also consolidated market by price. Every order book event, really? L1 data example. Show me. Fuck it, good enough. Yeah, whatever. This is different exchanges. Why is it? L2 does not capture every outstanding order. Direct sales. Wait, what? Outstanding orders. Okay, whatever. Oh, we're only going to have one. Wait, what is this? Hold on. Here, Investopedia. Just give me the picture. Give me the picture. Here, maybe this one. Show me the. Oh, here we go. Here's an example of level 1 market data for this. Oh, wait, that's it? Wait. Top of book. So all top of book information for trades, and give me the biggest one. Market by price. Consolidate. No, I don't need consolidate. I want the first thing. Bid price at top level, ask price at top level, every 1 unit. The sequence venue, TS size, order quantity, depth side. I don't see any arrays. Okay, well this is what, in theory, L1 data looks like. This is L2 data, which looks like, okay, so this is price and size. The full depth of bids and asks. So, different prices, and then L3 data, the full thing. So same price, different order IDs and sizes and modifiers, etc., etc. So that's okay. This actually kind of helps, but I feel like this is just their version of it. I'm not super convinced, but whatever. My point is, hopefully 1 million snapshots is enough. Yeah, probably is. So top bits of snapshot ID will just be taken. Let's do this. Make this explicit. Static U8. It can be U8. Static const U8. We'll call it like awaken bit. Like, oh fuck it, boot bit. Boot. Okay. Snapshot boot bit is equal to size of a U32, which is 32, I know, but it's the last one, so 31. So if we do, yeah, so if we do 1 snapshot boot bit, we get, if we do something specifically like that, we now have a snapshot boot bit that can be handled a little bit differently. We're also going to do this, which is going to be snapshot toggle bit. So this does limit us to these two are for clients, and they do limit us to only 2 to the 30 snapshots, but maybe that's okay. I mean, it's not a small number. It's like 1 billion. So that's okay. Maybe we can handle 1 billion snapshots. So we don't need this guy. We'll store it in the top parts of snapshot ID, which is really not just snapshot ID. It's also boot or toggle, socket toggle. So it's a socket. There we go. Booted socket. All right, cool. So. Shut up. What else? If a client gets a if a client gets a random snapshot pointer or ID, how does it know which L3, L2, L1 data it is? The handler. Somehow we'll pre-parse it before we get to the clients. Cool. So we have all this. We have client ID and snapshot ID. This is actually a single in 64. So we have this packets thing. Do we need a free list? Absolutely we do. Absolutely we do. Wait a minute. Oh, I was going to suggest we just use FL here for response, but that's not going to work because we do still need the client ID. Like packets are specifically for the server, so we only need like one. Like the destination is implicit here. It's implicit here. It's always going to the server, but here it's going to a client ID, so we can't just wake up everyone. We need to specify which client to wake up, so we can't do reserved IDs. But we still do need a FL. So FL star responses is equal to FL init size of response and 0. There's no reservations. No reservations. And what can we do with this? Responses is now this thing, so we can do. That's all good, fine and dandy. I wonder if you can pass types in C. That'd be interesting. Parameterize types. Anyways, so now that we have responses, let's go ahead and build one. So we're gonna directly build a response, and we're gonna set it up like so. Where is it? First boot. First boot. This is just timestamp, so that's fine. Or this goes here. It doesn't matter. But this boot event needs to change. So we're gonna do this. uint64 type boot event is equal to. It's not gonna be a boot type. It's gonna be a client in, and tmask parambits. I'm getting a little tired of doing this. I need to put in a separate one. And client ID. It's gonna be response ID and param mask. Oh, okay. So param mask actually limits us to a certain number of responses in flight at the same time. Now, what is response ID? Response ID is going to be this. This is U32. Response ID is equal to FL. How do we use FL? Insert responses, and for the actual response we want to do awake is equal to client ID is going to be client ID is equal to client ID, and then snapshot ID is equal to, I'm just going to say 0. This would usually be the actual index of the snapshot, but we're just going to do this. I hope this works too, because there's a whole bunch of 32 type whatever going on. Snapshot boot bit. Snapshot boot bit. And there we have it. That's our awake. Now we just simply get an address to that, and there you have it. Cool. Okay. So I know we have like a few levels of indirection here, but it's kind of the only way to deliver snapshots. We can't put a full fucking snapshot in the, wait. Yeah, we're just gonna have to live with the indirection, but oh well. All right, so we have this boot event. Let's see if we can actually get it out. So this is gonna be client in event. Let's just, what the hell? Let's just see if we can log it. Should be more like this. Oh wait, no. Wait. Something's off. Oh well. Let's just see what happens. Make main. Okay. 41 or 123. What else? What do you got for me? Response ID, snapshot ID. Where are you seeing snapshot ID? Oh, it's right there. What are you talking about? Is it not called snapshot ID? How do you? Are you dumb or something? Oh, you need to do the dot thing. Oops. There. Go. Go. Client int. Oh, client in. Client in type. There we go. And we got an infinite loop. Fantastic. All right, who's looping? Funny guy, huh? Must be new. While. What are we stuck on? Let me see this. It's weird. Printf client in type. Let's see it. Okay. Where are we hitting a while loop? What the hell? Why is log full suddenly broken? Okay. Wait, no, we did print it. Hold on, that's not it. Log full. Done logging. That's done. It's a server type, right? Printf Oh, we probably added something that broke it in the server code. But interesting that it's not a. Wait, what? We're done logging, but then type 3. What is type 3? Type 3 is a slow repeat type. Okay, so wait. Oh. We don't do anything in this case. Yes, we got a slow repeat types, but why is it not doing anything? Shit. Never enough damn time. It must be. Must be here. Yeah, I mean, it has to be in pop, right? Let's take a look at pop. I don't think I changed anything, so this is kind of weird. Yeah, I didn't change anything, so what's up? What's going on here, guys? Should be the last thing that gets typed. Yep, okay, so what's wrong with you? There's a while loop here. There's 2 while loops. Let's do this. Check the other one. While PQ is empty. Well, it's not empty. Something weird is going on here. Printf slow bucket not empty. Let's see. Okay, so it's not this one. It's this one. Why? You should have been rescheduled. Why didn't you reschedule the fucking other one? I don't have time for this. Ugh. I didn't change anything. What do you... Oh, I know why. Because we check against 7 and not the actual value. So we need to move them to a shared location. Let's call it vi include constants.h and then just move everything there because we need to have matching values. So all these static consts, let's just at least these. Let's just get at least these in there, and then we'll if not defined constants h. We'll do define and if. Okay, we're gonna add a lot more here, but for now this is fine. So we're gonna go back to the scheduler. We're gonna do import or include types or constants .h, and then instead of 7, dumb number, we're gonna do 3. Not this one, not this one, this one. What do we call it? Slow repeat type. There we go. Any other 7s? Nope. No. 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 Alright, let's get rid of them from main and import constants. And here we go. They were useful, but ultimately needed to be shared. So go ahead. Nice. Of course not. Types.h. Go ahead. Okay, cool. That's something else. We should probably get rid of invoked. Yes. Let's see, done logging. Okay, so we run that. That looks a bit better. I'm still not seeing. Oh, client in. Here we go. Does it actually do anything? Let's take a look. Raw is this, priority is this, type is 1, params is 8191, which makes sense. That's like the last one. It is a bit weird that we go from the back to the front, but whatever. I mean, this is good enough. We can handle, we can split this up into a few commits, but get, wait, how is this even being compiled? Oh, because it's in the include. Okay, git add include constants commit, moving shared constants to header file, and we can do what do we change in? Diff on source strategy. What changed here exactly? Whatever. The rest of these are get diff on source CB. What changed here? Okay. Important fix. Why did we change the scheduler? Git commit. Reworked the types. We only need 2 now. We only need 2 now. Next is getting a flow to work. All right, cool. Yeah, 366 deletions. That's good. Means we don't need everything. All right, cool. I'm gonna take a break. I gotta go